So in chapter 7, we did several things. First, find the, oh my goodness, I need to use the. So first we introduced how to find the area formula. If you have a picture like this, okay, and we want to find the area of this one. So the top is fx, the bottom is gx. The area is, well, you use a or s, is from, suppose this is a, this is b, x equals a, x equals b, is from a to b, fx minus gx dx. Okay. Well, sometimes you may have two different things. You may have the area in two different parts. Sometimes you may have this and then this. And even you got this is the x equals a, and you find this one is x equals c and x equals b. Okay, sometimes you may have this. You have to find out this area and this area. Well, in this case, you need to do them separately. Okay, in this case, you probably have to find the area separately. It's just a review of the whole chapter. So s equals, you do a to c, and you do gx minus fx. Okay, dx plus you do from c to b, and then the f is bigger, so you just use f minus g. Maybe I just write it here. This is another case. S equals from a to c, gx minus fx dx plus from c to b, then f is bigger, so fx minus gx dx. Okay, this is the first one we did area, which is pretty simple. The second thing we did is volume. Volume, we have two different formulas. Let me write it better. We did volume. Okay. Volume is, the first one is what method? Is disk method. Okay. Disk method you have is you just break them down into a lot of small disks. So one disk here, and then this whole disk is a circle, the circle disk. So for this one, you got the small one is pi r delt v equals pi. If you have r here, r squared times the dx. Okay, so you cut into a lot of small disks, then your volume, the whole volume disk method. The whole volume disk method is from, suppose this is x and y, and you have as a to b, and normally this is a to b. Okay, you are taking the derivative of the height. Okay, take the derivative with respect to height. This is the boundary, and you have to, this is the boundary point. Okay, so a to b and pi r x squared. The r is, sometimes r is changing. This one, the r is not changed, so r could be changed sometimes. R squared times dx. Okay, or you can have a to b, or sometimes v equals a to b pi r y squared. It could be a function of y, but you just have to make sure the same. Okay, they're the same. Y, a function of x, you take it with respect to x, but it's this way you take the derivative with respect to height. So this boundary actually is the height. Okay, this boundary is actually the height of the cylinder or another solid. Okay, and the second method after this one, because you might have a hole in the middle. That might be a hole in the middle, and then you have to subtract the hole in the middle. Okay, so second is washout method. Just review, let you have idea what we've learned in the whole chapter. The washout method is you have v equals pi a to b rx squared minus small rx squared and dx, or you have the same thing as pi a to b ry squared minus r squared y dx dy. Sorry. Okay, the washout method basically if there is a hole in the middle. And give you an example. If this is y equals sine x, if this is y equals sine x from 0 to pi, okay, you would like to rotate it with respect to a for example, you rotate it with respect to x y equals 2. You rotate it with this one. Then on the top you have another one here. So you'll rotate it here. Okay. And then what you can do, okay, you want to find this one, find the middle is an empty thing. It's empty like a donut. Like a donut in the middle is empty. But the outside is like a cylinder shape. Okay, the empty in the middle is like a donut, so you have to subtract it. So basically you need to this is r, and you have used the big R is 2, it's always 2. Like for example, big R is always 2. For this one, the big R is always 2, and you can know the small r, the middle small r, this one. For this, for example, the small one, you have to subtract the small one. Small one equals 2 minus sine x. Okay, then you can plug in and find the volume of the rotated region. Make sense? Washout method, subtract the middle hole, the empty part. Okay. Think about donut. You have a hole in the middle. You have used the whole thing. Subtract that the middle thing. Okay, the middle part. This is washout method. Then third one is what we did. What's the third method? Shell method. Yes. Okay. So shell method basically is you have a same cylinder. Sometimes the property is not a cylinder, but it's just a way to show you better to look at why is the shell method. Okay, so the shell method is pretty much like the paper tower. You take one layer out is a paper tower. Each layer is a rectangle. Okay, if you take each layer out, it's a rectangle. And this is 2 pi r, and this is times h. Okay, so you add all these layers together, it's going to be the volume. So the shell method volume is 2 pi r. You can do rx and times hx and dx. Well, then this boundary, the boundary, okay, from A to B, the boundary is going to be the radius. The radius of this the circle, the radius of the circle. Okay, since take one, take another one, you can see the radius is always change. Inside the middle, the center one, the radius is very small. You can tell the radius for this one is just x. Okay, the radius is always change. The outside layer is bigger, the radius is bigger. So the is take the antiderivative. The boundary is the radius. For the disk method, the boundaries are the height of the disk, or the height. Okay, so that's the difference between the shell method and the disk method. After the volume, what do we do next? Work, right? So when we did the work is much simpler, but the only thing you have to pay attention is W equals, you take F from A to B, so Fx dx. You should find the force times the distance. Well, the force is a function of x, it's not a constant force. So we did several force. The first one is spring. Okay, for the spring, we have F equals K times D. Okay, and we also did the second one is the Newton universal gravitation law. So the Newton's law. Okay, we also have that is the F equals K times M1 times M2 over D squared. Okay, so we have introduced these two, and also the pump the liquid out. So basically that one you have to use the F equals M times G. Okay, the G sometimes is given like Newton per kilogram or 62.4 pound per cubic feet, something like that. Okay, so this is the second time the work we did, and then after the work we did the moment. I think I didn't miss anything, right? So first one is area, volume. This is the shell method, third one, 3, 4. Did I miss anything? I think I didn't miss anything, right? 7.5 work. Oh, I think I did miss one thing. The length of the arc. So length of arc. Length of arc, you have basically have a length there. You want to divide this length to small pieces of segment, and then you add all the segment together is the length of arc. So you can use L as a length of arc. L equals, you take the integral from integration from A to B, and then for each one is square root of 1 plus f prime of x squared and dx. Okay, I think for each one is I have to multiply by the, let me say, for each one is that a squared. I think we have an x here. No, or x or fx. Let me check, double check it. Okay. Okay. So the length formula is there an x here? I believe we have an x outside, right? We have an x. Or just, huh? Oh, I think just that there's no x here, dx outside, yeah. It's the length formula. And the next after the, is one of the section we did, and then is a rotate, is basically rotate this, the same thing, you rotate this arc, you rotate this arc with respect to something, okay, you rotate it. I want to find the surface area. Okay, so the surface area of a surface area of this one, of this revolution, surface revolution. So basically, we're going to cut this surface into a lot of small trapezoid, Then the trapezoid formula is if you have a trapezoid at the top and the bottom and times the height. Look at that, okay. So the formula for this one is 2 pi times a to b fx square root of 1 plus f prime of x squared dx. Okay, basically this 2 pi fx is 2 pi r, is that you add the top, because the length of the trapezoid at the top is 2 pi r of this one. The bottom one is also another 2 pi r. So add together is 2 pi in the middle one r. And then, since they're very small, they're very close to each other. Also, this 1 plus fx squared, so it's just the L, is this one. It's the L is also the height of this, if you open up, it's the height of that trapezoid. Okay, so that's a surface revolution surface area formula. Now after that, then we go to last section, which is the last section is the moment, center, moment, mass, and center. Let me see. Last one is the center, moment, and center, and centroids. Okay, so this is the last one we're going to do for this chapter, and we have the moment. Give me 1 second. Okay. So we have the moment equals m, the mass times the distance, the length of the moment arm. Okay, that's the moment. Then yesterday we stopped at the moment at the centroids. Okay, so for one dimensional, it's pretty simple. Just add for one dimensional the moment of 1D is m times x. We just add everything together. For one moment, the center equals, you multiply all the mx and divide it by the total m. That's 1D. For 2D, two-dimensional, you also have, but it's different name. For 2D, you name the moment of y equals, you add all of the x together. Okay, mx1, m1 plus m2 x2 plus m3 x3 plus mn xn. Well, for the two-dimensional, you just name the moment as with respect to y-axis. But when you find the center, it's still the same. It's still add the x and the same. When you find the center, it's still, you add the x together. Okay, so mx1 plus m2 x2 plus mn xn over all the m together, m1 plus m2 plus mn. Okay, and for the other one is the same, but the moment of the moment with respect to x, okay, the moment is you add all the y, m1 y1 plus mn yn. But the center of yn, you see x and x, they are consistent, but this is just a name of that. Okay, so center of y is also my1 y1 plus m2 y2 plus, this is for discrete case. This is for discrete case, or point mass. Okay, mn. Okay, two-dimensional. We also have the continuous case. This is point. Okay, point mass. And then we have the planar laminar. Okay, it's planar. Just a name for it. Basically, it says the whole thing is going to be a two-dimensional plane. Okay. Something like this. Okay. And the bottom is y equals gx. And this is the whole mass of that. It's not a point anymore. The whole thing is have a density for each small piece. Okay, you have a density, you have the area. Since it's a two-dimensional, we don't have the volume. We need to find the m equals rho times the v, but this is just two-dimensional, so we just have rho times s. Okay. I will also have two formula for the centroids. So x equals, first is the mass. The mass is rho times s. The rho is a constant. You can always take it out. The s is the area of this irregular shape. So the s is kind of the same formula of the area. From A to B, fx minus gx. Okay, times, also because it's m times the moment, you have times the distance of the x position. So times x times dx. Okay, because the formula is mx. It's not just the mass. It also have to multiply by the moment of the arm. Okay, the length of the arm, which is x coordinates, x direction, x coordinate, and then divided by the total mass of this solid or this planar lamina. So you have to divide it by the total. It's rho over a to b fx minus gx dx. Okay, the y center, y direction is rho, because the y for a particular section, for a particular part, the y is in the middle one. Is the middle point. X is just one point. This is the x, but the y is the middle one of fx plus g. Okay, so the y, we take the average of fx, take the average of xx and the gx. So the y is the middle point, the y position. But the x position, because it's a really small piece, and the x won't change that much, so the x is just original x. So the only difference here, everything else is the same. A to b, fx minus gx, the same. But when you multiply by that, is half of fx plus gx. And this is the length of the y, or the y coordinates, because you have those two y are two separate, but we take the average of the y. So it's dx, and still the mass is from a to b, fx minus gx dx. This is what we stopped yesterday. Okay, and then do we do the problem? You stop at the problem. We have the problem, which is find the mx, my, and x and y. Okay, this is where we stopped yesterday. Example: applying the formulas, finding the moment of x, moment of y. Central is given. The equation is just really good on me thing. First the higher, so it's like that, and then okay. So it's this part. We're looking for this one. Okay, and then for the bottom one is we just do it from 0 to 1. Okay, from 0 0, and this is 1 1. And those two functions are given: y equals x squared, y equals x cubed. Okay, when x is between 0 to 1, we can tell x squared is bigger than equal to x cubed. Okay, if it's just in this area, x squared is bigger than x cubed, because it's 0.1, square is 0.01, cube is 0.001. So x squared is bigger. It's very important for us to know which one is bigger. Then the big one is y equals x squared. Then the lower one is y equals x cubed. Because why do we need to know that? Because we have to know which one is f, which one is g. Use which one, subtract which one. That's very important. Okay, we know which. Otherwise, you're going to have a negative number. So here we use the formula m. The mass equals rho times s. And since it was rho times v, because we're going to have two-dimensional, so we just do rho times s here. So the rho is s is the area of this one. The area from 0 to 1. And does it ask you where you find the mass? It doesn't say anything about the mass, right? So we can just directly use that formula if you want, but we can just do that. 0 to 1, x squared minus x cubed. As we said, x squared is bigger. We find the area. Okay, so just a ds. And then the m is going to be rho times s cubed over 3 minus x power 4 over 4. Take the energy, plug it in. So this is going to be rho times 1/3 minus 1/4. The whole thing is rho times 1 over 12. So it's 1 over 12 rho. Once we find the mass of this part of this object, then we have to find the moment. Okay, and we find the moment of x and the moment of y. So the moment of x, according to the formula, moment of x actually is the y direction. Okay, so it's rho times from 0 to 1. Is first is also the mx is also the square x times x cubed. Rho times s is the mass times distance. Moment of x is distance of y, but the center of x you still do the same thing x. Okay, half of x cubed plus square and dx. Okay, and then the mx will continue finding that. So the rho x cubed x squared, so it's from 0 to 1, half of x4 minus x power 6 and dx, and we'll take the antiderivative on this one. So it's half of rho times antiderivative of x power 4 is x5 over 5. Antiderivative of 5, the antiderivative of x6, so it's x power 7 over 7. You can take the 1/2 out, and then take integral, plug 1 and 0 into it. So you get 35, 7 minus 2, so it's 35 rho over 35. Okay. So I will give you 1 minute, let you try by yourself, find the my by yourself. Can you do the my by yourself? Okay. Okay, so did you find my? It's good to let you practice a little bit, right? Can anyone tell me how do you find your my, the moment of y? Anyone?
F of x minus g of x times x.
Yeah, rho of a to b, so a is still from 0 to 1. And then
F of x minus g of x.
so it's x squared minus x cubed, perfect, times another x and dx. So what's your final answer?
1 over 20 rho.
Yeah, rho over 20, very good. Okay, so now we have the mx, we did find that mx equals the moment of x equals the rho over 35. We find that my equals rho over 20. We also find the mass equals rho over 12. Then we just find the center. Center of x equals actually the moment of y over the m. Although it's just the name for that direction. My, you are actually doing the taking the distance of x. Okay, so it's rho over 20 divided m rho over 12. So the final answer is going to be 3 over 5. Okay, the center of y equals the m of x of m, but actually even I call it mx, moment of x, but you are still the length of the arm, the length of the moment arm is still y direction. Okay, so it's rho over 35 plug in rho over 12. The final answer is going to be 12 over 35. Okay, so then we're done at this one. Okay, so that's the whole thing of chapter 7. You can do some problems, some practice in your homework. It just applies formulas. It should be very simple. In your homework, a lot of problems are very similar as my class examples. Okay, so next we're going to do chapter 8. Okay. So do you have any questions so far? Pretty simple, right? Area, volume, work, arc length, surface area, evolution of surface area, moment. That's it for the chapter 7. Chapter 8. First, we're going to do some review as well. So more basic integration rules. Okay, and first is tangent x equals the antiderivative of tangent x equals negative ln cosine x plus c. The antiderivative of cotangent x dx equals ln sine x plus c. The antiderivative of secant x dx equals ln secant plus tangent. Also, the antiderivative of cosecant, we don't use this a lot, but I think we use more of the tangent and cotangent, and also secant more. Secant square, I'll tell you why. The other one is more as well. This one we use a lot more. This one, not the middle two. So negative ln cosecant x plus cotangent x plus c. Okay. And the next one is secant square. Secant x squared dx equals tangent x plus c. We use this a lot. Okay. We use this a lot. And sometimes this too. But we have used this one and also the other one, cosecant x squared dx equals negative cotangent x plus c. These two use more. Okay. Oh, and this one as well. Secant x tangent x dx equals secant x plus c. This is the same. When we do the trigonometry antiderivative, we're going to use these four formulas a lot, especially especially this one and this one. In the cosecant, but they are very similar. Cosecant x cotangent x dx equals negative cosecant x plus c. Okay. And also another one, antiderivative of dx square root of a squared minus x squared is its arcsine. Dx equals arcsine x over a plus c. And also arctangent, which we use a lot as well, dx over a squared plus x squared dx equals arctangent x over a plus c. We use this a lot as well. And the next one is dx over x square root of x squared minus a squared. This is 1 over a arc. I missed the 1 over a here, my bad. The other one has also have 1 minus a as well. No, this one not. So 1 over a arc sine, sorry, arcsecant x over a plus c. Okay. So now let's look at an example of the integral. Example 1. Two t plus 1 t squared plus t minus 4 dt. Okay, so for this one, I would like someone tell me what do you think I need to do here. Exactly, very good. We can do u substitution. Very good. Thank you, Nancy. So we can do the u substitution here. Okay. So if we let the whole thing, the denominator. Why is that? Because you see the derivative of t squared is 2t. Derivative of t is 1. So let u equals t squared plus t minus 4. Okay. Then du is exactly the same thing we have on the top. So 2t plus 1 times dt. Okay, then you just do u substitution. So the bottom is u. This together just give you the top 2t plus 1. So it's du. And the whole thing just ln u plus c. Well, it's going to be ln t squared plus t minus 4 plus c. Pretty simple, right? Once you see that u substitution part is pretty simple. Next one, 2 over 2t minus 1 square plus 4 dt. What do you think we need here on this one? I give you a little bit hint. Okay, the formula we can use 1 over x squared plus a squared equals, or miss a dx here, equals tangent inverse. My bad, I should maybe write it bigger. So is the formula you can use is 1 over x squared plus a squared equals 1 over a tangent inverse, which is arctangent x over a plus c. You can use this formula. Tell me if you can do that. Okay. I would like to give you a little bit time. Try it yourself as well. Can you try this one? Chapter 8 is a lot of antiderivatives, so you do a lot of practice. I would like to give you 2 minutes as well, and try it by yourself. Okay, so I would like to ask someone to help me. Maybe Zijian, have you finished it? Okay, so can anyone tell me what you got? What do you think we need to do?
I think we can take 2 out.
We can take the 2 out. You mean take the 2 out like this?
Yeah.
And then 1 over 2t minus 1 square. What do I do with the 4?
Plus 2 squared.
Okay, so what's next?
So we can like split it in half. Or it's going to be 1 over 2.
Okay, so since this is, compare this one with this one, compare these two. Compare x squared, a squared, this one squared, right? Well, it's better for us to do a little bit substitution. It will be much better. What do you think? I can do u equals 2t minus 1. Then this is going to be u, right? Because there is a ratio there between u and 2t minus 1. There's two complicated things. I don't want to mess that up. So just substitute that whole thing by a u is going to be u squared plus 2 squared. Anyway, probably say, oh, well, you have to worry about the derivative of du. That's not a big problem, because if I take the derivative of 2 du is 2, derivative of 2t is 2, derivative of negative 1 is 0, so it's 2 dt. Make sense? Okay. So if I do this u substitution with 2 plug it back, you have the bottom is perfect, u squared plus 2 squared. And the top is, I need to change that dt into du. Well, it's 2 dt as a du. Well, if I put this 2 into here, I don't change anything here. So suppose there's still 2 here. What do I have? I have 2 and dt, exactly the same thing what I need as a du. Does it make sense? Because 2 dt exactly the same thing as du. Well, sometimes it's not exactly the same thing, but it doesn't matter. It's just coefficient. You can make them one here and put another coefficient out. Okay. So then this is just a direct formula here. So then it's going to be half of tangent inverse of 2 over u. Sorry, u over 2. My bad. U over 2 plus c. Then it's half of tangent inverse of 2t. Plug u back into t, 2t minus 1 over 2 plus c. Okay. Let's look at one more example. How about negative 2x over square root of x squared minus 4 dx? How about this one? This whole section is a lot of substitution, u substitution. Okay, so just want to let you know there's another u substitution here. So we can, the most difficult part here is what? Is the square root of u squared, x squared minus 4. Is the bottom part is x squared minus 4. I don't want to do one part. I don't want to do the square root part. I don't want to do that part. But I want to do the inside, because the top it has exact 2x. The derivative of x squared is 2x. Derivative of 4 is 0. So that's perfect. I need a 2x dx. So let's just do, when you look at the problem, you have a quick estimation. So if I take the derivative of the inside of the whole thing, with the whole square root, if I do the whole square root, It makes it more complicated because I have a half of u times to the negative 1/2 power. Okay, so I just do u equals x squared minus 4. Okay, sometimes you do square root, but this one I don't. Because why I don't do that? Because if I do that, there's nothing cancel out with the square root. Okay. But here it's much better. If I take the derivative, du equals, take the derivative with respect to x. So it's du over dx is 2x. So it's 2x. Derivative of 0 is 4 is 0. So 2x dx. Okay. Well, this is exactly the thing I need for that 2x here. The top, although I have a negative, it's fine. But 2x dx together is exactly what I need here. So it's negative du. And the bottom is perfect. It's square root of u. And it's much simpler. So negative, you can take it out. And u to square root of 1 over square root of u is u to negative 1/2 and du. And the whole thing is negative u to... Okay, I want to stop here. Ask one student to help me with that. How about Nicknas? I think do you mind if I can Nick or Nicknas? Can you help me with this one? Yes. What do you think is u to negative 1/2 now? If I take the integral, what's that? U to negative 1/2. When you take the antiderivative of the polynomial function, you minus 1 or you plus 1? Okay, plus 1, thank you. Okay, so Nick, I think do you mind if I call Nick or Nicholas? I think that's your name. What do I divide? Just 1/2, perfect, thank you very much, just 1/2, okay? Because when you take the antiderivative of a polynomial function, you add 1 on the power, or the power function, you add 1 on the power, divide by the new coefficient. Basically, the formula is you take the antiderivative of xm is xm plus 1 over m plus 1, okay? That's the formula for the polynomial. As the calculus 1, you learn this one, okay? So now, everything's much better. Just simplify. Negative 1/2, you can bring it up, is negative 2. And the u to 1/2, this is negative 1/2 plus 1 is positive 1/2. So I can do u to 1/2 plus c. Okay? So just simplify a little bit, then plug back into the u. This is negative 2, square root of, s is square root of u, right? So square root of x squared minus 4 plus c. Okay, I think I will stop here. Tomorrow we're going to do more on the integrals, u substitution problems, which is chapter 8. Okay, chapter 8.1. And I'm going to stop here for today. If you have any question, oh, not tomorrow. Tomorrow is Friday, right? We're going to look at the homework of the whole chapter 7. The chapter 7 homework. Okay. Now, the previous homework. Okay. So I hope you can finish your homework 3 as quickly as possible. You know you have 5% extra credit if you finish before Sunday, or if you finish actually it's before Saturday, like on Saturday or not later than Saturday, have 5% of extra credit. Okay. And if you have any questions, just ask me. I think so far we're doing pretty good. Okay. If you need help, just send an email. You know my Skype account. I think I tell you my Skype account, right? If you need a face-to-face help, you can add my Skype. This is my Skype account. wufeng.tian. That's my Skype account. If you want face-to-face help, I have a big whiteboard in my office. I can give you face-to-face help and talk with you. I have a HD camera. And also I can use a Surface Pro to do face-to-face help with you, talk with you. Okay? Alright. So I'll see you tomorrow. Okay, good. Have you finished homework? Not yet. Not yet? Try any?
Yeah.
The first two, this is not same exercise,
Yeah.
and we give you help, like the same exercise to help how you do it. No,